Hello everybody, welcome into another lesson. So today we are going to talk about factoring by grouping. And basically by doing that, we're just going to look for what do each of the terms have in common. Well, we have 3 times the quantity of x plus y plus z times the quantity of x plus y. What do both of these terms have in common? They both have an x plus y in common. So you could pull that out, and then you just simply have 3 plus z for your other term, for your other part of the factor. And then if you redistribute this, you take x plus y times 3, you'll get 3 times x plus y, plus x plus y times z, you'll get z times x plus y. So your factors for this would be the quantity of x plus y times the quantity of 3 plus z. Simple enough. Alright, we got 7 times the quantity of r minus s plus t times r minus s. So, again, let's look for what do these two terms have in common. They both have a common quantity of r minus s. We'll factor that out right away. That just leaves you with 7 plus t. That's all it's going to leave you with for the other factor. So the answer for this, for the factor of this problem, would be r minus s, that quantity, times 7 plus t. Alright, we got f times the quantity of g minus h minus 4 times the quantity of g minus h. Alright, so again, let's look at these two terms. What do they have in common? Both of them. They have a common g minus h. You could factor that out. That just leaves you with f minus 4 for your other factor. So the two factors of this problem would be the quantity of g minus h times the quantity of f minus 4. So far this is really straightforward. Alright. We have w times the quantity of x minus y minus 8 times the quantity of x minus y. Well, let's look at these two terms. What do they both have in common? They both have a common factor of x minus y. We could factor that out. That just leaves you with w minus 8 for your other factor. So the answer you would get for the factors of this problem would be the quantity of x minus y times the quantity of w minus 8. Alright, we have 7 times the quantity of r minus s plus t times s minus r. Well, these almost look the same, but they're not. R minus s certainly does not equal s minus r. We need to make them equal. Well, what you can do first is keep your 7 times r minus s, take that plus the t times the quantity of, we can rewrite this as negative r plus s. We can rewrite that as negative r plus s, right? So if we do that, we almost get an equivalent expression, but not quite. What you're going to do is keep your quantity of 7 times r minus s plus your t. Now, what if I factored out a negative 1 from the negative r plus s? Let's factor out a negative 1 from the r plus s. If I go ahead and do that, negative 1 times what equals negative r? Well, that'd be positive r, right? Because negative 1 times r is negative r. If I factor out a negative 1 from s, negative 1 times what equals positive s? That'd be negative s. Well, what do you know? Yeah, because negative 1 times negative s is positive s. So I've now created two equivalent expressions in the two equivalent terms in the fact that they both have something in common. Let's go a little bit further before we factor. You'll have 7 times the quantity of r minus s, but if you take that t times negative 1, you'll end up getting negative t, so you'll have minus t times the quantity of r minus s. Now it looks like it's something simple that we can factor. You factor out a common r minus s. If we do that, you could factor out a common r minus s. Then you'll just have 7 minus t left for your quantity. So sometimes you'll have to get a bit creative. Sometimes you got to get a little bit creative to solve these by factoring out a negative 1. Sometimes that's your biggest line of defense to help you, is factor out that negative 1. So the answer you should get for this would be the quantity of r minus s times the quantity of 7 minus t. And I got more examples like this. I know that one was a bit of a doozy. I have another example just like it here coming up. Alright, I got 7 times the quantity of m minus n plus p times n minus m. Well, how the heck are we going to factor that? M minus n and n minus m almost look similar, but they're not the same. What we can do first, rewrite this as 7 times the quantity of m minus n plus p times the quantity of negative m plus n, because n minus m is the same as negative m plus n. Alright. Well, this is another one. We want to make m positive, right? We can do that by factoring out a negative 1. So you'll take 7 times the quantity of m minus n plus p. Let's factor out a negative 1 times the quantity of what? Okay, negative 1 times what equals negative m? Well, that'd be positive m. And then negative 1 times what equals positive n? Well, that'd be negative n. You distribute this, negative 1 times m is negative m, plus you have negative 1 times negative n, that gives you positive n. So now we have a common factor between the two terms by factoring out the negative 1. Let's go a little further before we factor. You'll still have 7 times the quantity of m minus n. Now you have plus p times negative 1, that'd be negative p. You'll have that minus p times the m minus n. And then we can factor out the common m minus n. Let's go ahead and do that. That just leaves you with 7 minus p for your other factor. So what you're going to end up having for your factors would be the quantity of m minus n times the quantity of 7 minus p. So whenever basically you have two terms that have almost identical multiples, but they're the opposite of each other, if they're the opposite, you can pull out a negative 1 as a factor to make it where you get the same factors on each term. You can pull out a negative 1, do that trick. So these will come up. Being creative like that often will help you solve your problems. Alright, we have 2a times the quantity of a plus 3 minus 3 times the quantity of 3 plus a. Well, a plus 3 and 3 plus a are really the same thing. In fact, what I would do is take a moment and write your second quantity to reflect that. You'll still have 2a times the quantity of a plus 3 minus 3, and then times that quantity, you have 3 plus a by the commutative property of addition. It's the same thing as a plus 3. Now it looks like we have common factors we can pull out from each term, which would be a plus 3. You'll end up having the quantity of a plus 3 times the quantity of 2a minus 3. So the answer for this problem is the quantity of a plus 3 times the quantity of 2a minus 3. So this is where knowing the commutative properties really come in handy. Alright, we have u times the quantity of v minus 2 plus 2 times the quantity of 2 minus v. Okay? At the moment we have no common factors, but v minus 2 and 2 minus v are opposites. So what you're going to do here is take your u times the quantity of v minus 2 plus 2, rewrite this 2 minus v by the commutative property of addition. 2 minus v is the same as negative v plus 2. You're going to rewrite it like that. And now in order to make v positive in your second term, you're going to factor out a negative 1. So you'll take u times the quantity of v minus 2 plus 2 times the quantity of negative 1. Now negative 1 times what equals negative v? That'd be positive v. Plus you have negative 1 times what equals positive 2? Well, that'd be negative 2. So now all of a sudden we got two common factors since you factored out a negative 1. Before we factor completely, let's do u times the quantity of v minus 2. Then we have 2 times negative 1. That'd be minus 2 times the quantity of v minus 2. Which would give you, now you have common factors of v minus 2. We'll go ahead and factor those out. That'll leave you with your other factor of u minus 2. So you'll end up having factors of the quantity of v minus 2 times the quantity of u minus 2. Alright, let's see. We have 2x times the quantity of x minus y plus y, whoops, I didn't write that right, plus y times y minus x. Alright, so we got factors here that look identical on each term. X minus y almost looks like y minus x, but they're opposites of each other. So this is going to be another one where we pull the negative 1 trick. You'll end up keeping your 2x times your quantity of x minus y plus y, but by the commutative property of addition, you could take your y and negative x and switch them around. You'll end up getting negative x plus y. So now for the second term, we need to make that multiple of negative x plus y. We need to make that x in there positive. We need to factor out a negative 1. So you'll end up having 2x times the quantity of x minus y plus y times that negative 1 you're factoring out. Now negative 1 times what equals negative x? That'd be positive x. Plus you have negative 1 times what equals positive y? Well, that'd be negative y. Now all of a sudden we have two common factors between both terms. So before I factor, let's go ahead and simplify this a bit. You'll have 2x times the quantity of x minus y. Then you have y times negative 1. That'd be negative y times the quantity of x minus y. Now we have two common factors of x minus y, so you could factor that out. You'll have that times the quantity what's left of 2x minus y. So the answer you should get for the factors of this problem would be the quantity of x minus y times the quantity of 2x minus y. Alright, let's see. We got 3p times 2q minus p minus 2q times p minus 2q. Alright, so we got 3p times the quantity of 2q minus p minus 2q times the quantity of p minus 2q. Well, 2q minus p almost looks like p minus 2q, but they're the opposite of each other. So first thing we're going to do is take our 3p times the quantity of 2q minus p minus 2q. We're going to rewrite that p minus 2q by the commutative property of addition. We can make that negative 2q plus p. Alright. So now we want to make the 2q in the second quantity, we want to make that from negative to positive. We want to turn that into a positive. We got to factor out a negative 1. So you'll end up taking 3p times your quantity of 2q minus p minus that 2q times your quantity of negative 1 that you're factoring out. Negative 1 times what equals negative 2q? That'd be positive 2q. Because negative 1 times 2q is negative 2q. Plus negative 1 times what equals negative p? Sorry, negative 1 times what equals positive p? That'd be negative p. So now all of a sudden that we factored out the negative 1, you have two terms with the same factors. But let's simplify this just a tad further before we factor. You'll end up having 3p times the quantity of 2q minus p. Now you have negative 2q times negative 1. That actually gives you positive 2q. You'll end up having plus 2q times the quantity of 2q minus p. So then we can factor out the common 2q minus p. Let's go ahead and do that. 2q minus p times your quantity, what's left of 3p plus 2q. So the answer you should get for this would be the quantity of 2q minus p times the quantity of 3p plus 2q. Alright. Let's see here. We have 2u times the quantity of u minus 2v plus u times the quantity of u minus 2v plus the quantity of u minus 2v. So we have three terms. Actually, I'm sorry, the middle term is not a u, it's a v times u minus 2v. My bad. So you got 2u times the quantity of u minus 2v plus v times the quantity of u minus 2v plus the quantity of u minus 2v. What do these three terms have in common? Let's start there. They all have a u minus 2v, right? So that just leaves you with the quantity, all right, you're just going to have 2u left plus v, and then u minus 2v, that just leaves you a factor of 1. So you'll end up getting the quantity of u minus 2v times the quantity of 2u plus v plus 1. And if you distribute this out, you'll get the original expression again. So we can't factor the 2u plus v plus 1 any further, so you get u minus 2v, that quantity, times 2u plus v plus 1. Alright, let's see, we have a times the quantity of a minus b plus 4b times the quantity of a minus b minus a times the quantity of a minus b. Well, there's a little shortcut here. I don't think we need to go through all the factoring, because you see a positive a times a minus b, then you see a negative a times a minus b. Those will cancel out. You're just going to be left with 4b times the quantity of a minus b. And this factors no further, so that would be the answer you get. So look for shortcuts like that in your expressions. If you can subtract and eliminate anything, by all means, feel free to do it. Why do that? We could have factored and done the long drawn out steps, but why? That don't make any sense if we don't need to do that. Alright, let's see. We have x times the quantity of 2w minus 3v plus u minus the quantity of 2w minus 3v plus u. Well, what do these two terms have in common? They definitely got the quantity of 2w minus 3v plus u in common. So that's just going to leave you with the quantity of x minus 1 for your other factor. So the answer you should get for this would be the quantity of 2w minus 3v plus u, that quantity times x minus 1. That one was pretty straightforward. Alright, let's see. We have r times the quantity of r minus s minus 2t plus s times the quantity of r minus s minus 2t. Well, let's look for what do both of these terms have in common. They both have a common factor of r minus s minus 2t. That just leaves you with the other factor being r plus s. And neither of these factor any further, so the answer for your factors is going to be the quantity of r minus s minus 2t times the quantity of r plus s. That's all you would get. Alright, this is a little bit different. We have s squared minus 2ps plus 2s, that minus the quantity of 2s minus 4p plus 4. Well, okay, this one doesn't look as straightforward. When you have a situation like this and you're trying to factor, but you have no common terms whatsoever to start with, take each term, factor each term individually. So your first term, you have s squared minus 2ps plus 2s. What's common to these three terms inside the first part of the expression? There's a common s, right? You factor out an s times what equals s squared? Well, that would just be s minus, all right, then you have s times what equals 2ps? Well, it'd be minus 2p, because s times negative 2p is negative 2ps, plus you have s times what equals 2s? Well, that'd be 2. So, and if you redistribute the s, you would get s squared minus 2ps plus 2s. So basically figure out what factor is common to these three terms and then go from there. Now you have minus, now here between the 2s, the negative 4p, and the 4, what do those have in common? They have a 2. So if you distribute, all right, 2 times what equals 2s? That'd be s minus, all right, 2 times what equals 4? Well, that'd be, well, I should say 4p. Well, that'd be 2p. And then 2 times what equals positive 4? That'd be positive 2. Well, all of a sudden, we now have two factors. We have two terms with two common factors. So let's factor out your common s minus 2p plus 2. You'll take that times the quantity of s minus 2. And that's exactly what you would get, because you cannot factor these any further. You would get the quantity of s minus 2p plus 2 times the quantity of s minus 2. I think we're going to make this a two-part lesson. I'm going to do 5 more examples with this one, and then we'll make this a two-part lesson, because there's a lot I'd like to cover. Alright, so we have x squared minus xy plus x, that quantity minus the quantity of y minus x minus 1. Alright? Alright, so it don't look like either of these terms is common yet. So we need to deal with each term individually, factor out each term individually. Start with the x squared minus xy plus x. What do these three terms have in common? They have a common x. So you could factor out that x times what equals x squared? Well, that'd be x minus x times what equals xy? Well, that'd be y, because x times negative y equals negative xy, plus you have x times what equals x? 1. So now you're left with x times the quantity of x minus y plus 1. Minus, okay, we have here we got the quantity of y minus x plus 1. Not quite a similar factor just yet. You have y minus x minus 1. That's really an opposite factor. First, let's use the commutative property of addition to rewrite this. You would get negative x plus y minus 1. Because that would be the same as y minus x minus 1 would be negative x plus y minus 1. Now, we want to make the x term positive, the y term negative, and the 1 term positive. We need to factor out a negative 1. So let's go ahead and do that. You'll take x times the quantity of x minus y plus 1 minus your factor of negative 1. Now, negative 1 times what equals negative x? Well, that'd be positive x. Negative 1 times what equals positive y? That'd be negative y. Then negative 1 times what equals negative 1? Well, that'd be positive 1. All of a sudden now you have two terms with the same common factor of x minus y plus 1. But let's simplify this a bit before we factor. You'll still have x times the quantity of x minus y plus 1. Now, negative 1 times negative 1, that's positive 1. You would just simply get plus the quantity of x minus y plus 1. Now, both terms have a common x minus y plus 1. We will go ahead and factor that out. So x minus y plus 1. Take that quantity times, you'll just have x plus 1 left over. And neither of these factor any further, so for this problem you would get the quantity of x minus y plus 1 times the quantity of x plus 1. Alright, I have 4 more problems here. Alright. We have 3t minus 3st. That quantity plus r. Actually, it's the quantity of, let's rewrite that a little bit. The quantity of rs minus r. Right away, nothing jumps out at you, right? Nothing jumps out at you as having common factors. So let's take each term individually again. Let's start with 3t minus 3st. Just focus on that piece. Well, what do the two terms have in common? 3t minus 3st. They have a, well, actually they have a 3t in common. Then if you take your parentheses and distribute, 3t times what equals 3t? Well, that'd just be 1. Minus, now 3t times what equals 3st? Well, that'd just be s. So you would get 3t times the quantity of 1 minus s. Plus, let's look at your second term. You have rs minus r. What do the two terms have in common? Definitely an r. You'd end up having the leftover quantity of s minus 1. Now these almost look similar, 1 minus s and s minus 1, but they're opposites of each other. We want to make, well, first thing we can do, take your 3t times your quantity of 1 minus s plus your r. We're going to use the commutative property of addition to rewrite this. S minus 1 is the same as negative 1 plus s, is it not? Now we want to make the 1 positive, the s negative. We can factor out a negative 1 on the second term. So you'll take 3t times the quantity of 1 minus s plus r times that negative 1 factor. Now negative 1 times what equals negative 1? That'd be positive 1. Negative 1 times what equals positive s? Well, that'd be negative s. So you have 1 minus s. Well, all of a sudden now both terms have the same common factor. But let's simplify this first before we factor. you'll have 3t times the quantity of 1 minus s. Now you have r times negative 1, that'd be minus r times the quantity of 1 minus s. Now we go ahead, factor out that common 1 minus s. You would end up getting the quantity left over of 3t minus r. So that is your answer, the quantity of 1 minus s times the quantity of 3t minus r. All right. You know, I think that does it for today. I think we have a generally solid idea of how to do these. Tomorrow I'll do factoring by grouping part 2. As a matter of fact, this may even be a 3-parter because there's different types of problems. I may end up doing different types of problems. So I think we'll call it there for today. I hope everybody has a good night. Take care.